Hi class, this is Samara Rashid online math class. This is the 14th lesson for geometry. We are still discussing circle theorems, but today I want to discuss three theorems in one. Yeah, you may see them as separate theorems, but they are under one heading we call tangent to circles. But we need to understand first what is meant by the word tangent. Yeah, I discussed part of a circle when I started mensuration. I discussed their part of a circle. So when we talk about a tangent, we have a circle like this. Yeah, not just a straight line, but any straight line that contact the circle. The straight line does not enter the circle. It does not pass through like this one. Yeah, the thing is that the line is a straight line. It contacts the circle. There is a point of contact, but it does not enter, it does not pass through the circle. So this line is what we mean by a tangent. So what happens when we have a tangent? What happens? What can we deduce? Which theorems can we have? Okay, we have the first one here. We need to understand, please, what this one is all about. The angle subtended sorry, the angle between a tangent and the radius. Yes, what is a tangent? Now again, this one is a circle. Yeah, the angle between a tangent and the radius. Tangent is a straight line. Radius is also a straight line. So the angle that lies between them. Now, the angle between a tangent. Look at the tangent. Yes, here is the center of the circle. So from the center of the circle to the circumference here is called radius. So the angle that lies between the tangent and the radius. Look at the tangent, look at the radius. Between them, there is an angle. This angle is what this theorem is all about. So between a tangent and a radius, that angle that exists between them is equal to 90 degrees. You see, the diagram is like this, but what I'm demonstrating is up. So this is telling you that it's not all about being at the bottom. It could be on the right hand side, it could be on the left, it could be somewhere slanted like this. But the most important thing is that we have a straight line as a tangent. What is a tangent? A straight line that touches the circle. It does not pass through the circle. So between the tangent and the radius, but there must be a point of contact. Nothing like we have a circle, we have a tangent, then we have a radius. No, this is not what we are talking about. The tangent and the radius, they must have a point of contact. It's supposed to meet somewhere. So when this one happens, the angle between them is exactly 90 degrees. This is what this one is talking about. The angle between a tangent, look at the tangent, and the radius, look at the radius, to the point of contact. You see, there is an emphasis here. To the point of what? Contact. They meet at some point. Tangent, radius, they meet here. That angle is 90 degrees. My question here is, how about this angle here? This is also 90 degrees. So this, we can deduce now that angle OBC, angle OBC is equal to 90 degrees. Yeah. How about angle OBA? Is the same. Yeah. So angle OBA, yeah, is also equal to 90 degrees. So OBC is 90, OBA is 90. So I hope this one is clear. All right. Now let's go to the second one. The second one is telling us that you can see, I don't need to remind you again that this one is a tangent. Why? Because it's a straight line, it touches the circle, but it does not pass through the circle. Okay, it only contacts the circle, it does not pass through. This one is also a tangent. So now we can see that This one is a circle. Within the same circle, there are two tangents. These two tangents, they do not lie on the same, they do not contact by the circle or on the circle. I'm sorry. The two tangents do not contact the same point. We have a tangent here, we have a tangent here. But the two tangents meet somewhere outside the circle. When you have a picture like this one, when you have something like this one, we can see that this tangent is equal to this tangent. So we can say from an external point, yes, or in fact, let me emphasize this. Let me use a word that can emphasize from any external point. From any external point. Look at an external point here. Let's call it T. From any external point, the lengths, plural, meaning not one, the length of the two tangent segments. We have this tangent, we have this tangent. To a circle, this tangent, of course, once you hear the word tangent, it means it touches the circle. So we don't need to say again, a tangent touches the circle. No, we cannot say the tangent touches the circle. Once the word tangent, it means a straight line that contacts the circle but does not pass through it. All right. So from any external point, the lengths of two tangent segments, 1, 2, to a circle are equal. So TA is equal to TB. I hope this one is clear. Lesson 15, of course, you will see the examples that I will solve, wherein we require the concept of these three cases on the board. So I hope this one is clear. Now let's go to another tricky one. Yeah, but you just need to be able to remember. It's not compulsory to memorize this. Just try to, if you can remember the picture, no problem. Yeah, just try to remember the picture of these things, be able to visualize them. You see, you'll be able to know that, oh, this is a particular or this is a specific theorem. All right, now let's come to this one here. You can see multiple lines, yeah, that seem to be confusing, but just pay attention. The angle between a tangent, but how many tangents do we have here? Do we have 1, 2, 3, 4? No, we have only one. Tangent does not pass through the circle. It only contacts the circle on the outside of the circle. This one is a circle. Is this a tangent? No. Why? Because it does not contact. This one is a circle. Is this a tangent? No, because it passed through the circle. Is this a tangent? Yes. A straight line touches the circle. This line is a tangent. So the angle between a tangent, we already have a tangent, but how many straight lines that meet this tangent? We have this straight line, it meets the tangent. We have this straight line, it also meets the tangent. Yeah. So the angle between a tangent and a chord, not chords, a chord. Now let us focus on one at a time. Let's forget about this. Let's consider this. Clear? All right. Now we are discussing the tangent and this. The angle between a tangent and a chord. Look at this chord. Look at the tangent. They form this angle. A chord, a tangent. They meet here. They form this angle. Right? Okay. So this particular angle that is between a tangent and a chord. But there is a condition what? Through the point of contact, the chord and the tangent, they're supposed to meet at some point. Okay? That particular angle is equal. That particular angle is equal to the angle, which particular angle next, that is subtended by the chord. Which chord? The particular chord that forms an angle with the tangent. So it is equal to the angle subtended by the chord in the alternate segment. Now, let me take off this so that you'll be able to understand what I'm talking about. Okay. let me leave the writing, then so you'll be able to see what I'm talking about here. Look at the circle here. This is a tangent. This is a chord, right? Now this tangent and this chord, they meet, they form an angle here. Yes, they form an angle here. A tangent, a chord, they form an angle here. This angle is equal to a particular angle. Which angle is that? Now, this one is a chord. If you have a circle and you have a straight line inside the circle that touches 2 points on the circumference, this one is a chord. A line that touches the circle outside is a tangent. So this angle is equal to a particular angle. Which angle is that? Now let's see the ends of this chord. Do you see the ends of this chord? If these two ends form any angle, not the part of where the angle is, on the other side, not where this angle is, because we are relating this angle to what another angle. So the chord and the tangent, this angle is equal to, now this one, if this one forms an angle here, that angle is equal to this. If this forms an angle here, that angle is equal to this. So if we have like this, so this angle is equal to this. We call this one the alternate segment. Alternate segment. The chord and the tangent form this angle. This angle is equal to the other angle this chord subtends. So this is equal to this. So here we double to tell you that these two are equal to these two. The next one is that we have a circle, then we have a tangent. Yes. This is a chord. This chord and this tangent, they form this angle. So if that chord forms another angle, not the side of this angle, somewhere, so let's say this, so this angle is equal to this. So because of we are dealing with the same circle, we differentiate, we have 2 max 2. So this is equal to this, this equal to this. We call this one the alternate segments theorem. All right, so thanks for watching. Don't forget to follow, like, share, and comment. See my next video.